Okay, now that you know all about digital logic gates and their symbols and their truth tables and when they're on and when they're off and so on and so forth under different conditions, it's time to apply those concepts. All right, so we're going to combine gates together in order to accomplish tasks, and we're going to make some control circuits in this video. So that's basically this especially. This is what you do with logic gates. You make control circuits. Basically any electronic device that you use is full of logic gates, and it's full of control circuits that do a wide variety of things, of tasks, based on different inputs and outputs. So that is the concept. It's really complicated to talk about what's going on actually inside, say, a tablet or a smartphone or a dumb phone even, which I like to call phones that are not smartphones. In any case, any electronic device has control circuits in it, pretty much, and those control circuits operate based on inputs and outputs, and they're basically digital logic. So let's just keep it in the real world, though. We'll keep it in more simple, easier to understand, easier to visualize situations. All right. So let's say, for example, that you automatically wanted to turn on some streetlights, like here on this highway is being lit by these streetlights. You don't want to have somebody go out there and turn a switch on every single pole to turn them on when it gets dark, and then go back out in the morning and turn them all off. Wow, how tedious would that be? It's much easier if you can have a control circuit that does that automatically when it gets dark and then turns them off again when it gets light outside. How would you do that? Well, you would use some digital logic. So here is an oversimplified version of how you might do that. Okay, so maybe simplified, not really oversimplified, but an actual control circuit would be more complicated than what I'm going to show you here, but this one would basically work. So here's the situation. You want a set of streetlights to turn on automatically when it gets dark outside, but you also want to have a master cutoff switch, just so that you can turn them off for some reason if you need to. All right? So you want to be able to override the automatic thing, basically, with a cutoff switch. So what does that mean? Well, if the light sensor and the cutoff switch are both off, logic 0, all right, so the cutoff switch is not activated, then the streetlights will be on. We're going to use a NOR gate for this, and I'll show you how it works. All right. You may remember that a NOR gate is an inverted OR gate, and that means that the only time that a NOR gate has an output of 1, the only time that its output is on, is when both inputs are off, or 0. You can refer back to the truth table for the NOR gate in the previous video if you need to. But basically the NOR gate, the truth table was only on, NOR gate only has a logic 1 when both A and B are logic 0. Otherwise, it's logic 0, it's off. All right? So, what does that mean? That means basically if it is dark outside, and if the master switch is inactive, so that's logic 0, then the streetlights come on. If it's bright outside, logic 1, the streetlights do not come on. And if the master cutoff switch is on, it's activated, then the streetlights will also not be on. All right? Otherwise, they're on. So that's how this is set up. You might be curious, how do you get a light sensor? Well, you would use a circuit that contains an LDR, a light-dependent resistor. The LDR, you may remember, changes its resistance based on the light that is striking its sensor. So you can set up control circuits that will respond to the light levels, and then you basically incorporate that into a light sensor. And then you can feed the light sensor's output into this NOR gate and use it to operate the streetlights. That is super cool. The switch, basically, it's just a switch. Flip it on or off, right? Flip it up into the on position and it turns off. It becomes active, so that's why I called it a cutoff switch. All right. Anyways, that's the first example that I'm going to show you. I'm going to show you one more example that is more complicated than this one, so bear with me. Okay, so let's say that you have a refrigerator, and this refrigerator is really crucial that it not get too warm. So if it's too warm inside, you want it to sound an alarm so that you know and you can do something about it immediately. Okay, maybe you're storing specimens for some kind of experiment or something, and you need the refrigerator to stay at the proper temperature. Okay, so you need an alarm if it is too warm inside, but you don't want the alarm to sound if you have the door open. All right, well, you're being silly if you're keeping the door open too long, but in any case, you don't want the alarm to sound if the door is open. Possibly that means that you don't actually have anything in there at the moment that you care about. In any case, we're just saying it needs to be closed up and dark inside. It also needs to be too warm inside. If those two conditions are met, it's too warm and it's dark, then the alarm will sound. Also, you want to be able to test at any time whether the alarm is working. That's a test switch. So basically, even if it is plenty cold enough, or if it's bright inside, you still want to be able to test whether the alarm is working. So these are the conditions. The light sensor has to be off, the temperature sensor has to be on, and the alarm has to be on. And also the alarm is on if a test switch is pressed at any time. So what does this look like? Well, logic 1 would be warm, logic 0 would be dark, logic 1 would be active for the test switch, and then logic 1 means the alarm is on. Alright, so how do we set up a circuit? You can see it's all set up here, but I'm going to explain it to you, how we arrive at this setup. Okay, so the light sensor is dark when you want it to be dark when the alarm goes off. You don't want the alarm to go off when it's light. Right. So logic 0 is the setting that we're interested in on the light sensor. Logic 1 is the setting we need on the temperature sensor. And we need both of those to be true. Both logic 1 and logic 0. I can tell you none of the logic gates we know will be active only when this one is 1 and this one is 0. That's too weird of a combination. So what we need to do is convert one of these two to something else. That's what the inverter is for. The inverter will convert a logic 0 for darkness into a logic 1 on the other side, right? Because that's what an inverter does. So this logic 0 will become a logic 1 after the inverter is finished with it. Okay? So that means now we have a logic 1 we can work with, and we have another logic 1 for the temperature sensor. So if we have 1 and 1, and we input them into an AND gate, that's going to give us an output of 1. Alright, so the output is 1 when both of the inputs are 1, and that means it is an output of 1 when it is warm and dark, and that's the conditions when we want the alarm to sound. Too warm, but also dark. Alright? We could, if that's all we cared about, we could just stick the alarm here, bam, put the alarm there, all done. But we also want a test switch. So we need one more part of the circuit, and that's where we're going to put an OR gate here. Remember, an OR gate, it will be logic 1 if either of the inputs is logic 1. So here we have an output from the AND gate that's used as an input for the OR gate. If the AND gate is producing a signal of 1, that means it's warm and dark and the alarm should sound. So put that into an OR gate. If this is a 1, the alarm will sound. Now we use an OR gate because that means we can also add a test switch. Normally this test switch will be 0 for inactive. But if we press it, like a little red press button, then it will be active, and that will be logic 1. And that would also turn the alarm on. Even if the output of the AND gate is a 0, the test switch would still activate the alarm. But if the output of the AND gate is 0 and the test switch is not on, that's 0, 0, and that's going to produce a 0. There will be no alarm. Okay? So that is a more complicated example of how you can use logic gates in order to accomplish certain control circuit tasks that you might want to do. All right, that's it for this video. That's it for digital logic. Obviously, we'll do more practice with this in class, but for now, that's it for the videos. I hope this was helpful, and I hope that you have an understanding and appreciation for how complicated your devices are and how many things they're doing for you on a regular basis in all of their little control circuits. So, thanks for watching, and we'll catch you next time.